Now we come to example 3 of the expansion of materials. We have a beaker here, glass beaker, completely filled with water. The dimensions of the beaker are given 9.9 centimeters in height, and the diameter is 7.4 centimeter. And then initial temperature of the beaker and the water is 54.7. Now let's say I heat this up, right? The final temperature is 95 Celsius. The alpha of the glass is given 9 times 10 to the minus 6, and the beta of the water is given 2.14 times 10 to the minus 4. So the glass beaker is going to expand slightly, right, when I heat it. The water is going to expand slightly. So what's going to happen at the end? Is the water going to spill, or is the water still going to remain in the glass beaker? So let's analyze what happens to this situation now, right? So let's calculate the initial volume of the glass, which is also the same as the initial volume of the water. The original radius is going to be 3.7 centimeters, pi r squared, and then the height is 9.9, right? 0.783, that's cubic centimeter, or you can say milliliters, right? So what's going to be the final volume of the water when it expands, right? The final of water is going to be equal to the 0.3 times 2.14 times 10 to the power negative 4, okay? Then add 1 to that, right? And then multiply that by 425.783, right? So the final volume of the water is going to be 429.455 cubic centimeters, right? So now what's going to be the final volume of the glass container? Well, the glass container's volume is going to expand mainly due to the fact that the side portion is expanding, the circumference is expanding, the height is expanding. The bottom will also expand, but we're going to ignore the bottom's expansion because the bottom's expansion is at a different rate than the side expansion. So at the end, what's going to end up happening is that it's probably going to be slightly looking like this. If you go like this, the bottom expands and kind of curves like this, right? And then the shape of the beaker changes slightly. But let's ignore the fact that the bottom expands at a slightly different rate. Assume that the bottom expands at the same rate as the sides, and we have still a shape that looks like a cylinder, like this, a perfect cylinder. Say this is the final height, and this is the pi times the diameter final, right? So let's find out what the final circumference is and what the final height is, right? So let's calculate the final height of the glass. 9 times 10 to the power negative 6 times 40.3 plus 1 times 9.9. So the final height of the glass is going to be 9.90359 centimeters. Right. Now let's calculate what the new diameter is going to be. The diameter final is going to be the initial diameter, 1 plus alpha delta t, right? So it's going to be 7.4, 1 plus 9 times 10 to the minus 6, and then 40.3. Now what do I need to do? My ultimate goal is to calculate the final volume of the glass, right? The final volume of the glass is going to be what? So keep in mind that this was the final height. The final volume of the glass is going to be still the same equation, pi times the radius final squared times the height final, right? So basically I just divide this by 2. Our final is going to be d final divided by 2. Okay, so now you can see that the final volume of the water is larger, right? 426. So the water expands more because it is a liquid, right? So some of the water is going to spill. So how much of the water will spill? Amount spilling is going to equal, well, subtract 429.455 minus 426.246. Then we get 3.209 milliliters or cubic centimeters, right? So about 3 milliliters of water will spill from the sides, right? So you can do different kinds of problems like this, have different materials and different beaker materials, and we can try and see if the water will spill or will the water just rise but not spill, okay? So thank you very much.